Okay, we're just going to run through a bunch of examples today. The first one is the power rule. Notice when we do the derivative, this 8 will come down. The new power will be 7. The 3 comes down, new power is 2. We talked before about how this is just a line, so the slope of a line is just the m. The line is y equals mx plus b. So the slope of this line is just going to be the m, in this case 2. And then we multiply 8 times 10, get 80. 3 times 9 is 27. And that's it. Okay, derivative 5 to the x is going to be 5 to the x, and then ln of 5. Derivative for e to the x is e to the x, and ln of e, but ln of e is just 1. So really you just get e to the x. Derivative for log base 7 of x is going to be 1 over x, but there's an extra ln of 7 in the bottom here, and that's because it's log base 7. This one's log base e, so you'll have ln of e here in the bottom, but you don't have to write the ln of e. Okay, here's an example of the chain rule. We're going to pretend that this is all just an x. So it's kind of like x to the 10. Here we're writing u to the 10. Derivative of u to the 10 is 10u to the 9. But then we say, wait a minute, it's not just an x, it's a bunch of stuff. So we got to do the derivative of all that stuff. The derivative of that stuff gives you 7x to the 6 minus 3, and then you're done. Now don't forget, you cannot leave it as a u, so you got to trade the u for whatever u was equal to. Final answer. Okay, this one is just an example where you have to rewrite it. Remember, square root is a power of 1/2. So we'll have to bring the 1/2 down, and the new power is going to be 1 less. So 1/2 minus 1 is negative 1/2. Now the inside was sine of x. So because it wasn't just an x, we need to do the derivative of sine of x. And that's cosine of x. Now you can actually stop there. If you're like me, you like to rewrite it and make it look nice. The negative power on top would come down, and it would become positive power on the bottom. So you'd have positive 1/2, which is a square root. You have the 1/2, and then from the chain rule, we have cosine of x that goes on the top. And that's it. Now, one of the derivatives you want to try to memorize is the derivative for square root of x. And that'll just save you a bunch of time. If we had remembered that, we could have just written as 1 over 2 root sine. And then we say, wait a minute, it's a sine instead of just an x. So the derivative for sine is cosine. So the chain rule would be just to multiply by cosine. And it's so much faster if you can just remember the rule. So the derivative for square root of x is just 1 over 2 root x. So just try to remember that. Okay, this one's a rewrite. We have an 8 on the bottom. If we move that piece up to the top, we get negative 8. So you'll notice this is a quotient, but we don't know the quotient rule yet. Okay, when we do the derivative, it's just a power rule. We're going to pretend all of this stuff is just an x. So the negative 8 will come down, and the new power will be 1 less. Some people put negative 7, but 1 less is actually you subtract 1, so you get minus 9. Remember, the inside is not just an x, it's a bunch of stuff. So we're going to have to do the derivative of that stuff. Most important part is don't forget the parentheses, because we're going to have 2 pieces here. We're going to have a 5, and then plus e to the x. And if you don't put the parentheses, it's going to be completely wrong. You could rewrite this if you want to. Again, you don't have to rewrite it, but if you did to make it look nice, your answer would look like that. Okay, first step on this one is to rewrite it, so it's just a power. So it's kind of like x to the 5. If it was x to the 5, your answer would be 5x to the 4. But it's not an x. The inside is tangent of x. So we're going to have to do the derivative of tangent, and that would be secant squared. And that's it. That's your final answer. Okay, this is a rewrite example. Remember, this power of 4x can come down in the beginning. then you would be left with 4x times ln of e. But ln of e is 1, so it cancels. So really, you're just doing the derivative of 4x. You could think of this as a line. Remember, the slope of the line is just a number in front of the x, so in this case, 4. So this derivative is just going to be 4. Same thing over here. This is just a rewrite. We have e to the log base e. So that's all going to cancel, and you're just going to be left with cosine. Derivative of cosine is negative sine. Okay, now I'm going to do the same problem but 2 different ways just to show you get the same answer, and you can decide which way you think is easier. On the first one, we're going to bring the power down, so the power of 3 can come down. The derivative for ln of x is just going to be 1 over x, and bring down that 3. So you get 3 over x as your final answer. You could leave it like this. Your answer would be 1 over x to the third, but then you have to do the derivative of x to the third. The derivative of x to the third is 3x squared. Now we have to do some canceling. So I can cancel these 2 x's and I can cancel these 2 x's, and my final answer is 3 over x. So I got the same answer. Again, why can I cancel x over x? Well, there's 2 reasons. Number 1, we know x cannot be 0 because you can look at your original derivative. We have ln of x to the third, so it's obvious that x cannot be 0. Another way is if you just look at your final answer, you can still see that there's an x in the bottom, so we know based on our final answer that x cannot be 0. And that's the reason why we can cancel an x over x. Okay, remember the rule, if it was the derivative of 2 to the x, your answer would be 2 to the x ln of 2. But here, instead of an x, we have a function, so we have 2 to the sine of x. We'll go ahead and put the ln of 2, but we're going to have to do the derivative for sine of x. The derivative for sine of x is cosine of x. So we'll say times cosine of x. And that's it. That's your final answer. Now over here, we kind of treated it like a u, so if you prefer to do it with a u, that would be fine. But I think it's faster if you just do it this way. Just solve it as if it was an x, and then the very last step, say, wait a minute, it wasn't an x, it was sine of x, so we got to do the derivative of sine of x. And this part right here is the chain rule. Okay, if you remember, the derivative of e to the x is just e to the x. Now we don't have just an x, we have a bunch of stuff, so we're just going to have to do the derivative of that stuff. So just doing it the fast way, we have e to that power. And again, because this is not just an x, it's a bunch of stuff, we're going to have to do the derivative of that stuff. It gives us 3x squared minus 2. And that's it. Again, you can look on the side, they're doing it with a u substitution. It's a little bit slower doing it that way. Okay, we know the derivative for sine is just cosine. But we have a problem. The inside is not just an x, it's a bunch of stuff. So we're going to have to do the derivative of that stuff. Now this is a quotient, we don't know the quotient rule, but we can rewrite that as a power of x. So I'm going to write this as x to the negative 3. So I'm going to do the chain rule on x to the negative 3. The derivative for x to the negative 3 is negative 3x to the negative 2. Remember, you can leave it like that if this is the AP test. I prefer to rewrite it because I'm not taking the AP test right now. And if you rewrite it, this is what you get for your final answer. Again, you can look over here on the left side. They're showing you how you do it with a u substitution. Just pause the video and take a quick look.